Alright, so for this lesson we are going to be discussing how to use pointers to directly manipulate data in memory. So in an earlier lesson, you saw that text is encoded as individual ASCII characters where every character occupies exactly 1 byte or 8 bits, and every character is stored in memory one after the other in order to form a string of text. We also learned that because each memory address only contains 1 byte of actual memory, that therefore each ASCII character would have its own unique address in memory. Let's review this by going back to our 16-byte RAM example and look at how the string of text ABC123 is actually stored if we were to store it at position 8 in RAM. It would look like this. Oops. There we go. Okay, so at position 8 we have A, and then position 9 B, and then C, and 1, 2, 3, and of course, if this is a string of text that is 2 quotes surrounding the string of text, that means it is a null terminated string of text, which means we're going to have our null character at the end. So this is how the actual string of text is going to look in memory. So let's create a pointer called PTR, which we will give the address of the first character in the string. So let's say address in memory of the A, which means in this case position 8. Now remember, this is not valid code. I'm just describing what it is I want to do. I want to create a pointer called PTR that is going to contain the memory address of the first character, which is the A, which therefore means in this example position 8 in RAM, assuming our RAM was 16 bytes in size, which of course it isn't in any real computer. So for right now, don't worry about how to actually do this. Just understand that I've given the pointer PTR a value of 8, which is the memory address of the A character in the 16-byte RAM. Now, we learned that the asterisk character takes on a new meaning once the pointer has been created. When you create the pointer, the asterisk means you're creating a pointer. When you use the pointer later on in the program with an asterisk, here you are saying what is at the address of PTR, for example. Now again, that's not, I haven't finished this. I could, if I wanted to, I could write int some integer equals 5, and then PTR equals address of some integer, and then I could do that, and of course the output would be the value is 5, assuming that I wrap this all in a valid program. I just want to make sure that you know how that works. Alright, so once again, what I'm trying to do is to create a pointer called PTR, which is going to contain the address of the A character. That's my goal. That's what I'm trying to do in this example. So first of all, let's imagine that the string of text, in this case ABC123, let's assume that this string of text is already in memory at position 8, just like as in this example. So we are assuming that the string of text already exists in memory and that the memory looks exactly like this. So somewhere in memory we have the string ABC123. We know that at the start of that string, whatever address that is, there's going to be the A character. At the very next byte there's going to be a B character, and then a C, and then so on. We don't know where in memory this is, but we know that somewhere in memory this string of text exists. So now recall from the earlier lesson that if PTR is a pointer that contains the address of something. In this case, PTR contains the address of 8 in binary right here. Then star PTR or asterisk PTR means whatever is at that location. So in this case, star PTR would be set to the exact binary value for the lowercase a. So when you say star PTR, you are saying the actual data stored at that memory location. If you change that data, you change the A character itself. Think about it. If we make a change to the data at position 8 in memory directly, well, then we have changed the value of that character. For example, like so. So by directly changing this binary sequence, we can change the character that is contained in that byte. So here I've changed it back to A. All I need to know is the memory address, and then I need a mechanism by which I can change what is located at that memory address. In fact, we could change it to anything we want. By using a pointer, you can directly manipulate the data inside any memory address, and therefore you can change the data itself. Alright, so how do we do this? If we assume that our pointer contains the memory address, 8 in this case, which is where the thing is that we want to change, how do we actually change it? The answer is you just simply write what is at that memory address equals to whatever you now want it equal to. Like that, for example. So if I were to write this line of code, I have actually went here and changed what is at that location in RAM to AB. Just like that. And if I wanted to change it back to an A, I would write that. So in other words, when you write star and then the pointer, you are saying what is at that memory address. That means you can use it to retrieve data. Like in the printf statement, you can say, I want to print what is at that memory address. Or you can directly manipulate the contents of that memory address and change it directly using a pointer. Now, what is very nice about that method is you can use a pointer to change the value directly in memory without even creating a new variable or without using any additional space. So if you imagine that you are limited to how much space you have, you can use a pointer to go through all of the data, 1 byte at a time, changing it, and you won't have to use any additional space. So let's go back to the state in RAM that we started with. So here is our starting situation. We have a string of text ABC123 somewhere in RAM. Somehow we have assigned a pointer the address where that string of text begins, which means the pointer contains the memory address where the A is located, which in this case is 8 in binary. Now if I change that by writing, now let's say this, then what happens is the byte right here at position 8 in memory gets changed. Well, again, it's going to start off as an A. This is how A would look. It's going to get changed to become AB, like this. So the A is gone, as if it never was. When you change the data directly in memory like that, you have altered the actual bits in that byte at that specific location in RAM. Whatever used to be there is simply gone. So the A is not copied somewhere, it's not made into a variable, it's just simply replaced with the B. Now if I was to write star PTR equals C like that, well then the entire byte is going to be changed so that it becomes AC. Notice I've done all of this in just 1 byte. I haven't had to use any additional bytes or variables or anything else. I've just created a pointer, pointed it to a specific location in memory, and then using the syntax of star pointer name equals, I'm able to change what is at that memory address to whatever I want. So remember, whenever you create a variable and give it a value, and then later on you use a pointer to change that value, then the original value is lost. Here, I'll show you an example. All right, so let's write out a simple program here. So let's start by creating an integer. We'll call it total. We'll give it a value of 5. Now we'll create a pointer and give it the value, which is the memory address of total. So now somewhere in memory, there is, of course, this is an integer, so it's going to be more than 1 byte in size, but just for the sake of simplicity, imagine that it's 1 byte. And basically, somewhere in memory, the actual binary for the number 5 is going to be stored. In truth, it's probably going to be as 4 bytes. But this is what it's going to look like with a bunch of preceding zeros for the bytes other than the last one. So we're really looking at the last byte here. But somewhere in memory, there's going to be a memory address for the total variable, and it's going to be set to 5. So if I change that value by writing like so. Now what have I just said? I've said what is at the memory address of my pointer, set that to 10, which means that it will now look like this. Where did the 5 go? The 5 is gone. The memory location, which used to contain a 5, now contains a 10. I have changed the memory directly. So remember that when you change a value like that, the original value is gone. So now let's write a printf statement to demonstrate it. First, we'll do it like this. Now I'll run this. So notice what it says. The value is 10 because we have said what is at the memory address of my pointer is now set to 10. So when I print the value is star my pointer, I'm saying what is at the memory address of my pointer, and so that value is 10. But notice what happens if we do this. If I change star my pointer to total, watch what happens. Still 10. Why? Because my pointer contains the actual location in memory where the variable total is. So by changing what is at that location, I have changed the variable total. So whereas total used to look like this, which is 5, it now looks like this, which is 10. I've changed the actual data in memory directly using a pointer. So think about this. Consider what is happening. We are saying let's create a pointer that contains the memory address of the variable total, and then let's use that pointer to replace whatever was at that memory address with a new value of 10. This means that the variable total itself has been changed. The old value of 5 is gone forever, and it now has a new value of 10. So in this lesson, you have learned that you can use pointers to not only look at memory directly, but also to change memory directly. So to recap, you now have 3 things you need to remember about the star syntax in a pointer. When you create a pointer, you use a star or asterisk to create it. For example, int my pointer with a star in front of the pointer name. When you wish to see what is at a memory address of a pointer, you use the star character. For example, printf, the value is my pointer, like so. And just for the sake of simplicity, I'll put this here so you can see the syntax highlighting. So this is an example of using the pointer in order to see but not change what is at a particular memory address. Why isn't this used to change it? Because I haven't put an equal sign. If I put an equal sign, then I can change it. So lastly, 3, to change what is at a memory address, you use the star asterisk syntax like this. Star my pointer equals 10. And now whatever was at that memory address gets changed to 10 in this case. So this goes back to something we also discussed, which is why it is important to remember the different data types that you can assign to a pointer. If I write int star my pointer, then I've specified that this pointer is going to be used for integers. This is very important because when I change the value at a specific memory address, I must change it correctly. If I had this set, let's say, for a short int, which let's say occupies 2 bytes, and then I create an actual integer which is not a short int, and I call it total, and I give it the value of 5, and then I assign my pointer the address of total, and now if I try to change it and I set my pointer equals 10, I'm going to have a problem because this 10 thinks that it's only going to occupy 2 bytes, when in fact it needs to occupy probably more than that, probably 4 bytes. The data type must be the same. So if you have a need for working with pointers for integers and short integers and long integers, then you should create a pointer for each one, not use a single pointer across different data types. There are ways to do that, but that's beyond the scope of this lesson. So, to summarize what I just said, you must remember that the data type that you give to a pointer must match the data type of any variables you are working with. So if you create a variable called int total and you give it a value of 5, then if you create a pointer that's going to work with that, you're also going to say int. That's all. It's not complex. If I create a character variable called myChar and I'm going to create a pointer to work with that, I'm going to create char pointer. It will also be the same data type. So no matter what data type you use for the variable, use the same one for the pointer. So if I do an unsigned short int sum variable equals 20, then the pointer that I would use would be unsigned short int star this pointer equals address of some variable, like so. All right, this concludes the lesson. So in this lesson, I've shown you how you can use a pointer to directly manipulate the data at a specific memory address. And again, the way you do that is you just write just more or less like this. You just put a star in front of the pointer name, then an equal sign, and then whatever the new value is. For example, int total equals 5, int my pointer equals the address of total, star my pointer equals 10, and now I've effectively done the exact same thing as if I had written total equals 10. Same thing. All right, there you go. If you have any questions, feel free to ask.